My name's Maria McCoy, and I've been a data management consultant with Leading Resolutions for over 10 years. I've been working in the data management space for 24 years, half of which has been in consultancy, with engagements completed across more than 20 client companies. I'm here today to talk about the importance of managing your critical master and reference data, to explain the value proposition for why this data is so important, describe some of the methods and tools for managing this data, and also describe some of the architectural options to integrate and harmonize master data across your enterprise. We probably have a mix of people in the audience, some maybe more strategically focused and some more operational facing, but it should be useful for anyone to get a better grounding in the terminology and technology surrounding master data and be able to talk about the benefits and options with greater confidence. Whilst this section is sector agnostic, there are some elements that might apply more to manufacturing or retail sectors because master data management tends to be a bigger competitive differentiator for those sectors. Finally, I'll also cover off a case study where we've mapped and harmonized master data for one of our clients. So the first section is about understanding what master data is and some of the key terminology. At the core of master data management, or at the core of data management, is the recognition that not all data is equal. Some data is critical to the operation of the business and other data is less so. Some data is volatile in nature and other data is static. This diagram represents some of the types and subtypes of enterprise data, demonstrating where master data fits. In layman's terms, master data is where you have data about a specific thing and that there should be a consistent set of correct data that accurately represents that thing. So taking supplier as an example, at any one time, you'd want information to accurately represent that supplier, their company name, the contacts that work for them, and details of any agreements that you might have with them. Master data management is about deciding how you control the quality of that data and use it effectively across all of your business processes. Here in the model, we have master data split into two aspects. We've got enterprise structure data, which is data that enables business activity to be reported or analyzed by business responsibility. So typically we're talking about the structure of an enterprise and its people. So employee, department, financial structures like chart of accounts or budget codes, cost centers, that kind of thing. Transaction structure data is data that represents the direct participants in a transaction. So we're talking about things like customer, supplier, product and service. This data requires controlled amendment processes to ensure that there's a correct and consistent enterprise view. And then we have reference data. And I must admit, I tend to flip-flop back and forth as to whether to have reference data as a subset of master data, because it is in some literary references, so it's useful to know that. But because the definition of things are different, I'm not sure it is truly a subset. However, they do tend to have similar control mechanisms. But anyway, reference data is used to categorize data or relate it to the outside world. It's basically lists of things. So things like sort codes, country codes, currencies, categories, groups, subtypes and types, anything which typically has a drop-down list of allowable values. And therefore tables containing this information tend to have just a few rows and columns. So here are some common master data terms to help you in having conversations with your architects or third-party vendors, for example. So I think we've already covered master data and reference data. So next is master data management, shortened to MDM. This is the core process of acquiring, managing, governing, enriching, and sharing your master data according to your policies and business rules. Master data can be managed using spreadsheets or various big business systems like ERP or CRM systems. However, to automate the process of managing master data, many organizations decide to have some kind of dedicated MDM solution or hub that's capable of connecting data silos and providing clean master data records to any business systems or processes that need it. Next, we have data hierarchies. So this refers to the organization and classification of data elements. At the top, you might have something broad like product, And then under this, you could have different product types or categories or classes. And then further down, you might have stock keeping units and their attributes. Having consistent hierarchies can be key for product recognition and understanding performance across the business. So one example is when I worked for a client who specialized in short-term, low-value loans. And in one country of operation, a short-term loan was considered to be 1 to 6 months, and a long-term loan was considered to be 6 to 24 months. But in another country, a short-term loan was 1 to 2 years, and a long-term loan was 2 to 5 years. So when head office wanted to compare the performance of their long-term and short-term loans, they weren't comparing apples with apples. So understanding these key hierarchies is really important when analysing the performance of your business. The next few terms can get a bit tricky because they are system of origin, system of record, and system of reference, which all sound a bit similar, but hopefully this should help you to understand some of the differences. The system of origin is where the data was created, but generally within businesses, we consider that to be when it lands on the company-owned databases or infrastructure, so not where it was created by, say, a third-party data supplier. Good examples might be a web portal where the customer registers their login, or a recruitment system where you capture potential employee data for the first time. Then we have a system of record, which is the authoritative source for a given data element or piece of information. It's where data about an entity, either the whole thing or just attributes of that thing, is created, captured, and maintained. I tend to use the term authoritative source a bit more often, but that's just a personal preference. Next is the system of reference or source of truth. This is a trusted data source that gives a complete picture of the data object as a whole. So in cases where your system of record is for the whole object, it's also the system of reference. But where your system of record is only for a few attributes, like you've got employee performance information in this system and then employee training records in another system, then you can pull the information together from these different systems of record into a single system of reference. Ideally, it provides users with golden records, which are the most accurate and complete representation of an entity's data. Which brings us on to golden record or single view. The golden record is the consolidated master data record based on the most trusted information. One unified, trusted version of data that captures all the necessary information needed to know about a customer, product, a supplier, etc. Golden records eliminate duplicates and inconsistencies and inaccuracies by combining data from various sources. For example, if a customer's address is stored differently in multiple systems, the golden record would provide a consistent, accurate address. Okay, so now we have a good understanding of the key terminology. Let's have a look at the value proposition of master data. This is the basic value triangle for data. Applying this to a master data example, a common value realization is the desire for excellent customer insight into demographics and spending patterns for marketing, cross-selling, and other commercial benefit. But to get to that, first you need some foundational elements. You need to know where all of your customer data is. You need to put controls in place to be able to manage the quality of that data, to link different sets of data, such as customers' web browsing patterns with their transaction history, with their demographic data, and then to extract all of this for reporting purposes, being mindful of data protection regulations and other factors along the way. So there's a lot more effort required to build the base of the triangle, but that then makes the data exploitation at the top to drive the value realization much quicker and easier to do, with a high degree of confidence in the resulting decisions. So broadly, we implement master data management to achieve things like competitive advantage, to increase revenue by improving visibility and access to accurate customer data, and quicker routes to market by improving product alignment and automation for how this data flows through the systems. We want to reduce risk, so regulatory compliance is a big one here, such as financial reporting and data privacy requirements. You need to understand where all of your personally identifiable information is and to manage the quality of it in order to apply data protection controls properly. There's also increasing effectiveness by enabling strategic goals such as customer loyalty, supply chain excellence, strategic sourcing and contracting, geographic expansion, and market effectiveness. And then there's increased efficiency. For example, productivity improvements across the organisation by reducing duplicate, inaccurate, and poor quality data. And poor quality product and service data, and streamlining the related business processes. Additionally, major data issues are one of the top 10 reasons for ERP project failures. And even if you implement an ERP system successfully, the root cause of up to 50% of ERP trouble tickets can be master data related. So this is definitely something to seriously think about as a precursor to any major ERP program. So although we've covered some of these talking about value realization, I thought it might be useful to go through some common master data management use cases to help bring this to life. So use case 1 shows that citizen data is to public sector organisations as customer data is to businesses. In this first example, a city council needs to improve citizen data quality for the effective administration of emergency services. They'd need to set business rules and establish a trust hierarchy and create a citizen golden record. This would enable better logistical delivery, meeting legal obligations, and provide better analytics to improve their service. Use case 2 is a financial institution that requires a single view of the customer to satisfy FSCS regulations. They would need to create a single customer view from multiple systems, which would not only enable compliance, but also create a 40 million customer record database to be available for marketing and risk analysis. Use case 3 is a distributor of technical equipment that suffers from no collective buying, stock transfer difficulties, and falling behind competitors. So they build a single product catalogue and break the product names into attributes, thus increasing product recognition, improving stock management, and enabling product substitution to increase their profits. Use case 4 is a car manufacturing organisation that has a short customer relationship, but they improve their customer master data management and introduce car security systems and grow their servicing and parts revenue stream to differentiate themselves from competitors, thus breaking into new markets, having more revenue and more profits, etc. Use case 5 is an IT service company improving their cyber certification, so they decide to rationalize and unify their identity management for all employees to improve data protection compliance, have a less complex IT estate, and support single sign-on for security controls. The final one is a telecoms company with a high customer churn that create a single customer view at household level and use predictive analytics to look for customer segments with low churn, thus getting increased customer retention and saving money on new customer acquisition. So hopefully that gives some context for how master data can enable beneficial business outcomes. So in this how-to section, I'll cover some approaches, tools, and architectural options relating to master data management. First of all, let's go through some handy hints and tips for how to map and model your master data. Here you can see a section of an enterprise conceptual data model from one of our client projects. A conceptual model is something that I like to try and tackle for our clients because it's high level, it's easier to maintain than more detailed logical or physical data models, and it's non-technical, so people in the business tend to find it quite engaging. With the way that we create them, they provide a rich source of foundational information to support things like master data initiatives. The first thing is the color coding. We tend to have one color for each major domain of data, such as client, product, supplier. And whilst not all domains are master data domains, for example, finance is more about transactional data, it still gives a really quick visual way to see all of the data that relates to customer at a glance and how it connects to the other concepts within the business. The second thing that this model gives us is a way to express hierarchies using the box-in-box notation. So here you can see we've got customer in the center, and a subtype of customer are the consumers. So those are the individual recipients of the products. And then you have your business customers as well, which are then further split into UK customers and international customers. And you can see that international customers there is connected to customs documentation. So not only does this give you a really good way to clearly define your hierarchies, you can then be more granular about which business concepts relate to different elements of the data. The third thing that this model enables us to do is to tag it with which of the key concepts are master data, reference data, and transactional data by the use of the different borders around the color blocks. So we've got customer data in the middle with the black line around it, that denotes master data. And then we've got retailer categories and currencies, those are reference data items. And then with the light gray line around, we have event or transaction data. So things like customer complaints and customer orders. So zooming out on this model a little bit, I just wanted to point out that you can often identify key master data within a model because of the hierarchies and the fact that so many lines connect to it. You know, as critical data, it's useful for so many different business processes and it has all of those connections. It's like a locus of activity. So in this model here, we can easily see where the customer data is with the hierarchies and all of the lines. And we've got employee data, lots of lines going to it, not any hierarchies, but still shows that it's a hub of activity on the model. And then similar for product as well, with the subtypes and the lines. The only anomaly on this one is supplier data, where it doesn't quite show so much as being a master data domain in that visual way. But, you know, more work on this model would probably build that out and actually show more connections than what might be represented here. Here's another example of a data model, this time a logical data model, which is a lower level of granularity showing entities and attributes. This isn't specifically one that I created for a client, but it's a good example of tagging data models with these key classes of master data. In this case, it's been tagged with reference data, transaction structure data, and transaction activity data, which were the subclasses of master data that we covered earlier. So defining what our master data is one thing, but we also need to map out where it is and try to determine or agree which is the most authoritative or master source. There are a number of data cataloging tools that you can buy to help with automated discovery of data structures and content within all of your data stores. But if you want to do this manually, I'd again recommend starting at a high level. You can do this for all of your master data or just for a subset of data that is in scope for your MDM improvement initiative. This slide shows a tool that we've used for several clients in the past. By putting key data items down the left-hand side of the spreadsheet, you can then map out where that data exists across your systems. At first, this might just be a check mark to say, yes, this data exists here. But as you get into your analysis, you can start to discover whether that system is where the data is initially captured, tagged here as source, whether it's considered to be the master, and whether it is actually being fed to that system as a downstream system from somewhere else. This tool doesn't currently show the directional flow of all the downstream systems, but you could always tag them as Fed 1, Fed 2, something like that, to express a daisy chain of system integrations in a specific order. This high-level map can immediately show you some potential risk areas. So for example, with price book there, we've got two different systems claiming to have the master of the price book. So that could be a stakeholder perception that needs to be managed, or it might be that one system masters some attributes of the price book and another one masters other attributes, in which case you could split that price book row out into two data items potentially. Another area of risk here would be the product terms and conditions. So we can see that there are multiple sources, so that could create conflicts of data, but also no system is actually claiming to be the master. You can also create an as-is and a to-be map like this, and then analyze the differences between them to see what needs to change in order to achieve the eventual goal of having clear capture points, good downstream system flows, and clearly agreed authoritative sources. So next we're going to look at how master data can be assured through good data quality management. Data quality management is a key aspect of master data management. There are generally 6 widely known data quality dimensions used to describe these different aspects. They are validity, accuracy, timeliness, uniqueness, consistency, and completeness. And it's actually the latter 3 that come more into play for master data management. Uniqueness is important because poorly managed master data can have duplicate records for a single entity. For example, 2 accounts have been set up for a single customer with a different email address, or multiple records have been set up for a single supplier by different people in the business. The way in which you eliminate these duplicates will depend on what the data is. So for product data, for example, it's likely within the gift of your own organization to control and dedupe where required. For things like supplier or client company data, you can potentially use an external reference source, such as Companies House, to correct it. But for individual consumer data, it tends to be a bit trickier. You could use your call centers to help cleansing or prompting consumers upon login to update their own data, but it's much more difficult to enforce and to know for sure which are the correct records. Consistency is also important because it indicates the extent to which all systems reflect the same information and are in sync with each other across the enterprise. In order to see whether the data is consistent, first you need to be able to match a single record from one system to another. If you've got common identifiers in different systems, this could be straightforward. But in most cases, there's some kind of lengthy ID mapping to actually ensure you're comparing the right things with each other. Scoping is also key. Initially, start by comparing just a few fields for consistency. So, for example, product name and status, or company name and registration number. And then you can build in more attributes to get them aligned from there. Completeness also comes into play because even if you've got 100 supplier records on system A that match to 100 supplier records on system B, it might be that system B actually has 200 supplier records, indicating that the full picture might be missing from system A. This makes it important to match consistency in both directions between systems. So in that previous example, matching from system A to system B gives you a 100% match. But if you match system B back to system A, you'll only get a 50% match rate. So your overall data alignment metrics should be an average of all these pairings. This slide is an example, very much based on a true story. So on the left, we show the couplings of systems and the fact that we need to match both ways in every combination. And this also means that when you improve the data in one system, you might therefore see an uplift across several combinations of the match stats. And similar to how you can gradually add more attributes that you want to match against, you could start with just 2 systems, get those matched and cleansed, and then gradually add more systems to cleanse and align. On the right, the graph shows how we have seen these sorts of matching stats progressing on a client case study. In this example, we started at around 60% match rate for product data. And through analysis and batch cleansing in various systems, you see the occasional step change jump in the statistics. But the other interesting thing that we see in practice is that between these batch cleanses, the stats gradually degrade over time. This indicates that there are some system and process controls that are required to stop the poor data from coming in the door. And it's also a bit of a warning to everybody that if you don't actively manage and monitor your master data after a cleansing project, it will gradually revert back to poor quality data. We sometimes see that with things like ERP implementations. All the data gets cleansed. If you don't manage it, it does gradually degrade over time. Master data improvement can't just be a project activity. It has to be a day-to-day discipline. Okay, so now we're going to have a look at some potential master data management architectures and solutions. Before we start looking at some more complex architectural options, I just wanted to point out that the simplest and least costly way to manage master data is to design your processes and data flows to be unidirectional if possible. So by unidirectional, I mean that data is captured, it comes in, and then it flows from authoritative sources to downstream systems for use and does not get updated in those downstream systems. So by having an architectural principle to ensure that your data is only ever updated in your master data set and flows down, you can take more of a data quality approach to master data and avoid having to purchase and implement a master data hub of any kind, which can be costly and time consuming. However, if data flows are much more complex and you need master data solution of some kind, there are a number of factors that may influence this, and some are captured here. Semantics. So how are you going to map and understand the data from multiple sources? Data quality. How are you going to monitor and cleanse data? What about survivorship? Depending on your situation, this can be a huge factor. If you've got multiple data sets with data in common or being updated synchronously, you need to specify rules for which updates take precedence in the event of a multi-update conflict. You really need to understand your data and your business processes to be able to do that, because it's no small task. Then we have data privacy and data ownership. A governance structure is required to ensure clear lines of responsibility and promote adherence to standards and regulations. And there's also data scope to be considered, which can be important with MDM solutions because it can massively impact your licensing costs. For example, some MDM solutions charge per golden record that you create, so the solution for product data might cost a fraction of the same solution for consumer data. Data access is also a consideration. Can we pull the golden records into a system for reference overnight and then just use it for read-only purposes? Or do we need the data harmonized in real time? That will impact your solution decisions and design. Then we have data diversity, the sources and uses of data, and there may be unusual data types that you need to handle, like unstructured records or geographic data. Data velocity and volume is also a factor. How quickly does the data change and how much of it is there? All of these things need to be considered and captured as requirements to feed into any MDM solution designs. So what sort of master data architectures are there? There are 4 key ones that we're going to run through today. The first is registry style. In this architecture, you've got various source systems that publish their data, and an MDM hub stores the source system IDs and key data values. It builds a virtual golden record of that master entity by matching and merging records pulled from these connected systems. It doesn't send any data corrections back to the source systems, but it can make those golden records available in a read-only capacity. So in some situations, this can be really useful so that you can analyze the data and have that golden record whilst avoiding the risk of overwriting any information in the source systems, which is especially important where you have to maintain audit trails or a chain of custody for that originating data. It gives you that single view through a low-cost data integration and relatively short time frame with minimal intrusion to your source systems. However, your source systems are not harmonized or fixed in any way, and that single view can't be used in a read-write capacity. So next we have the consolidation style. And with this, so this is basically an upgraded version of the registry style with an added layer of data stewardship. With this style, master data is also consolidated from multiple sources into the hub to create those golden records. And typically they're used for reporting and reference purposes. Unlike the registry style, there tends to be some human inspection at that hub too, to make decisions that maybe can't be made through automated means, or to double check the data and make corrections where needed. Consolidation hubs are inexpensive and quick to set up. They provide a fast and efficient way to facilitate enterprise-wide reporting, because this style is mainly used for analysis, giving you a trusted source of data for reporting and analytics, which is why you see on the diagram the information being brought in from several systems and then funneled to a BI platform. There's also coexistence style, which is a slightly upgraded version of the consolidation style, where the insight from that data validation, merging and corrections that happens in the hub are then looped back to the source systems. So you start getting benefits to the source system data, improving operational efficiencies, but it is more complex again to implement because there needs to be data quality capabilities, workflow, integrity checks, and perhaps a number of accountable roles that manage those source systems and are required to handle these corrections without introducing any additional risk. And then the final one is the transaction or centralized style. In this architecture, the MDM hub stores, enhances and maintains all of the relevant master data. It becomes the authoritative source of truth and publishes this valuable information back to all respective source systems. The MDM hub needs to support the merging of records and also the splitting of master records. The centralized style allows you to create master data within the hub, making it a system of record. And if you centralize all of your data creation functions for supplier, customer, and product domains into the hub, it becomes the system of origin as well. Technologically, this architecture requires more complex rules, more intensive data reconciliation and data synchronization, and thus it takes longer and is more costly to implement. It may also require major changes to your business processes to centralize master data creation away from the source systems. On the plus side, the hub serves as an authoritative source of truth. Source systems are harmonized, data quality is monitored centrally, so your master data is accurate and complete at all times. The centralized style can often evolve from consolidation or coexistence styles as you mature your best practice and secure additional funding. So the final thing I wanted to say about solutions and architectures is that there are some specialist software packages that have been designed for specific master data use cases. One is commonly called CDI, or Customer Data Integration Tools. These are MDM hubs specifically designed for customer data. They'll include out-of-the-box features for things like deduping, fuzzy matching on name, address formatting corrections, and have inbuilt privacy considerations such as data masking for data protection compliance. The other is PIM, or Product Information Management. They tend to have out-of-the-box features that help with ensuring consistent product names, product life cycles, product versions, and also managing longhand text such as product descriptions. While these tools can reduce setup time due to their inbuilt features, you've got to be sure that you've got your strategy well planned, because if you go for a more niche tool, that might leave you with less flexibility in the long term if you then want to expand the scope of the data that you're mastering at a later stage. So now we're going to have a little look at some of the roles and accountability that sit around master data management. So why do we need to govern master data? MDM is not just about implementing technology. We're governing people and processes, so accountabilities and escalation procedures must be clear. MDM won't work long term without active governance. If you remember back at that graph earlier, the quality and accuracy of master data will erode over time, and processes will break down, and people will forget their training unless you actively monitor and correct issues as they arise. And people need to carry out these activities as part of their defined roles. MDM spans multiple departments and divisions and trading boundaries, which also means you've got to closely manage key stakeholders. Many people may feel a sense of ownership about the data that's created in their systems. So this is another element of hearts and minds and people and process. Often this can be handled through domain-specific governance forums, and then you can invite representatives from each system so that they're given a voice in any decision-making. MDM supports many business and IT initiatives, so a single governance routine is required to support them all to reduce process redundancy. What you don't really want are processes cropping up in silos around the business with differences in how accountability sit or how data corrections will be handled. The model on the right is a Gartner view, which includes the governance and process elements as important layers. And if you work from top to bottom, from 1 to 3, the actual solutions and infrastructure to bring it all to life comes last. So in this slide, I wanted to explore a dedicated master data team and what it might look like and the sort of things they may do. I'd like to thank renowned MDM speaker Gerard Bartley for this slide, as he's shared his materials with me at a recent master data conference for reuse. This model comes from a large chemical manufacturing company who require 100% accuracy of product and supply chain data, and they achieve that through a diligent team. In its extreme, such a team could be 30 or 40 people large, although in most cases it's going to be much smaller than that. On the right, we have data governance, which is fairly standard. Allocating, managing and training data stewards and owners, maintaining the corporate glossary and data definitions, and the capture and change control of key reference data items, lists of values, or LOVs as they're called here. We also have data quality, which is fairly standard, maintaining the data quality standards catalogue or rule book, supplying data quality reports, and helping projects with major cleanse activities. But the other two aspects of model management and data maintenance are a little bit more master data specific. So in this model, the data maintenance team actually capture all product and supplier records. So people in the business cannot create this data. They have to send forms to the data maintenance team. And if there's anything incorrect or missing from those forms, the data maintenance team throw it back to the business until it's 100% correct. Then it's submitted for upload to the system. The data model manager is an interesting one too, because I think of data modeling typically as being part of a data architecture and design function. But in this case, the master data team closely guard the data model for all master data attributes, their structure and standards. They work with projects to ensure that any existing master data or new master data is strictly governed, and they can advise and ensure any data integration activities to make sure that they have appropriate use and formatting of those master data attributes. So what lessons can we take from this model? Some key considerations are who enters the data, your MDM team or the business. There are pros and cons either way. So with a controlled data entry point, you'll be enforcing a major data quality gate and ensuring high quality data from the outset. But it would be too disruptive for many businesses and business processes to actually do that. And it might also, there might not be much appetite for the business for this data entry to be taken away. So the next one is who fixes the data. Having a central team to fix the data is often quicker than trying to convince people in the business that they have to do it. But people in the data team are much further removed from the operational use of that data, so it introduces the risk of error. For both of the above, sizing the team appropriately is crucial to avoid any bottlenecks. It's also important to articulate how these roles should interface with other related functions. So the model management might link with IT architecture. All of the different functions need to link with the PMO and the change functions. IT engineers can enable a lot of this stuff as well, and the data quality rules should handshake with your BI and analytics functions. So these are just some examples, but working through various scenarios and articulating the responsibilities of all the different parties can really help to bring an organizational model like this to life. So the final section is a case study and some lessons learned. We had a 3-year engagement with Experian, which included many things, implementing data governance for their internal data and supporting a commercial transformation program. But one of the key things we were there to help with was to align product and client master data across internal operational systems. The primary driver for this was IT service management. So when a corporate customer phones up with a problem, their information was entered into ServiceNow, but to find out what product they used from a drop-down list of 3,000 and to find their company record when there are so many duplicates or complex company structures was a tricky thing. This caused delays and a drop in customer satisfaction. So we set about mapping and improving the product data across their internal systems by understanding the flow and lineage and painstakingly correcting it across each system. Sorry, I've just lost my place. Finding it back. We also mobilized data governance roles in forums for product and client data to help us with this task. So one simple example was that we requested system changes to filter on only the UK products so that the call center staff had only 400 products to choose from rather than 3,000. This may seem simple, but actually getting change requests through for a regional purpose on a globally governed system was not a quick and easy thing. So when we talked about model management earlier and ensuring the consistency in how data is used, there were people in North America who were naturally trying to resist making changes that were region specific. So they were doing a good job, but we were able to put across the case and convince them of the benefits. And actually there were other regions who found this change to be really beneficial to them too. So you'd think that aligning a list of 400 product names wouldn't be that hard a task, but don't underestimate the level of engagement you might need with the business and the number of micro decisions that might be required. So some are simple fixes like the difference of a space character or a capitalization or a hyphen, but there are much more complex examples as well. Experian are a company that acquire and rebrand products regularly, so that means that product names change, and these names are entered manually in some systems or might be fed through to other systems. You can end up with residual older product names here and there, some because it's how the customer knows it and they don't want it to change on their invoice, or in other cases, maybe it's hard coded somewhere because there was a temporary workaround to a problem that was never backed out. So those are just some examples to show how it can be far from simple. So then we started mapping and fixing client data, which was even more of a beast at 20 or 30,000 records. But we were able to establish a reference source of company data against which we could then cleanse some of the key data sets and improve the automation of this data to downstream systems. But we had to tread very carefully every step of the way. Winning hearts and minds played a major role. It took a good year or so for the sales team to realize that this wasn't just some non-commission making admin task that we were asking them to do, that it would make a major difference to how they communicate with and sell to clients. But once they got it, we started making major strides with data cleansing and alignment. So in terms of success stories, we delivered a new data quality capability, which was hugely popular with many business stakeholders, and data alignment KPIs were being tracked at the very highest levels of seniority. We assured product life cycles, so a product might be in beta mode or available to buy or being retired, and there are a number of statuses and date fields related to this, like go live dates and end of support dates. We captured these business rules and cleansed everything, made sure it was all aligned, and then accurately flowed to downstream systems. We also get an improved customer journey by having consistent client and product data from sales processes through to billing, invoicing, and customer support. And we enabled strategic programs. So within the commercial transformation program, they were implementing a new configure price quote system, which required accurate and consistent product data. We'd already done the cleansing for this, but if we hadn't, there could have been a delay of like 3 to 6 months to that project to get the data fit for it to proceed. We also improved integrations and automation by mapping out the data lineage and spotting opportunities. And because the changes we were making were seen as positive for other regions, the UK became an exemplar for global adoption of best practice. So finally, some key takeaways. You need a strategy and clear requirements. You need to have very clear scope and outcomes from the outset, as that will shape a lot of what needs to be done, your investment and the tooling decisions, for example. Data quality tools are a prerequisite. At its core, master data management is about good data consistency, and you need some data quality capability to be able to profile and monitor the consistency of data across your systems before you even really get started. You also need to capture all the benefits and track them closely. For Experian, we tracked the data alignment, which we could see improving every time we did some cleansing activity, but we were also tracking some higher order benefits, things like customer satisfaction scores and billing corrections, which were our ultimate aim, but it wasn't really until all of the data was aligned for product and client that we'd start to contribute towards these metrics, and there were many other factors that would contribute towards those metrics. So measure everything you can and track the uplift across the piece. Also, simplify your architectures where possible. Decisions on things like MDM tooling are a major investment decision. Even if you do have master data being updated in multiple places, first you should challenge that. Can we change or simplify our data capture processes to reduce this and move towards a unidirectional flow? Simplification and standardization up front will exponentially reduce the long-term cost and complexity of the solution you need to manage your master data. Invest in a data team appropriately. This is not a side of desk job, but you also don't want to create an unnecessarily massive team in a cottage industry of bureaucracy. Ideally, you want to implement an efficient, effective, low-cost processes for maintaining master data adequately size your team to sustain momentum and avoid bottlenecks. Aligning master data is a hard slog. Don't underestimate the engagement with subject matter experts that you'll need to do and the hearts and minds you'll need to win along the way. Your converts can become your strongest allies. And then finally, just like a puppy, master data is for life, not just for Christmas. Treat this as an ongoing BAU activity embedded into your business and not a project activity. So that's all I have for the main content. Do you have any questions?
Thanks, Maria. That was a very comprehensive run through. Thank you so much. So yeah, are there any questions from anyone? Feel free to put it in the chat or the Q&A functionality. It should be at the bottom bar of Zoom for you. Lots to go through. If I've one from me, Maria, just listening to you, if someone believes that their situation is quite complex, but they're not sure, where's the best starting point?
So I'd say mapping your lineage. So what I mean by that is saying, our product data is here and it gets fed to here. So that master data map, you can do that at a high level. It doesn't actually take all that long. And that will immediately show you, where data, if it is being captured in multiple places, and the directional flow of your data. So that's the first step, I'd say, in terms of understanding the complexity. But also, I think, if you are thinking about master data, if you're thinking you've got a problem, there are usually some pain points that you're feeling. So, start capturing those where possible to form a potential business case. And what's really difficult with data business cases, and it's kind of an irony really, but often when you're trying to build a business case, you don't have the right data to prove that business case. So, we often know that many people are wasting a lot of time wrangling data, but you can't get the metrics and measures for exactly what that time is that's being wasted. But as a good example, from the Experian perspective, we had one of our analysts actually, sort of monitor some sales calls and using a timer, actually see how long it took to look up product data, how long it took to look up client data. And then we factored as to, that actually took quite a few minutes to do. And it should be as easy as, sort of 10 seconds at the most. So by reducing that time, you could save like 3.5 FTEs or something like that. So once you can do that analysis and capture those data points, that helps you build your business case as well. So start thinking about that stuff early on when you realize you've got some pain points.
Perfect. Thank you. Anyone else? I think you might have answered every question, Maria, by going through everything so well. I'll give it a few more moments to see if anyone's got anything to put into the chat.
Apologies for my vague technical failure as well. My script laptop died towards the beginning, so
you wouldn't have
a little bit of a
hiccup. We're all used to it in the world of on demand and Zoom and what have you. I don't think there's any questions. So what I'll do after the conclusion of the webinar in a moment is I'll make sure to share the slide deck and the recording with everyone that was here. But from me, thank you so much for coming, everyone. Right, I'm going to end the webinar now. Bye, everyone.
Bye.